First, we need to learn a couple terms about chemical reactions. So, if we look on here, on the left side of this reaction, we call those the reactants. And then, so that's what goes into the reaction. What comes out of the reaction, what's made, are called the products. Alright, so since we're going to talk about reactions that release energy first, here's what these would look like on a graph, okay? They'll start here, or they'll start at some amount of energy, but there's that activation energy that has to be input for a reaction to move forward. So that looks like a hill on this graph. There's a certain amount of energy that has to be overcome for the reaction to go forward. But once the reaction goes forward, it will end at a lower energy than it started because it releases energy. So then this, remember, that's our activation energy. Okay?
Let's start by looking at reactions that release energy. A fire is a great example of a chemical reaction. Now, burning or combustion, this is a chemical reaction that releases energy. And we know that because it makes us warm. It gives off light. That's energy that it's releasing. But even reactions that release energy, a lot of times they don't just start on their own. I have this pile of wood here, and it's not just bursting into flames. That's because it requires activation energy. There's a certain amount of energy that has to be put into this to get the chemical reaction to go. Now I provide that activation energy with a match. So let's try it out. Well, that match didn't work.
Reactions that absorb energy, those look slightly different on a graph. We still have our activation energy that has to be overcome for the reaction to go forward. But then, our end of the reaction, our products, end at a higher energy than we started at because it's absorbed energy.
Alright, now let's look at a reaction that absorbs energy. Some reactions don't release energy, they absorb energy. So here, in this jar, I have some vinegar. And what I'm going to do is I'm going to put baking soda in there. Now this is a reaction that absorbs energy. And so you'll notice that when I put this baking soda in there, it's going to get colder. That's because it's absorbing energy from its surroundings. So here we go. Got this baking soda. Whoa! Let's watch the temperature. It started going down. Still going down. So there you go. It absorbs energy, so the temperature went down. A catalyst is something that increases the rate of a chemical reaction. It helps it to go faster. Enzymes are catalysts found in living things. They increase the rate of chemical reactions in living things, and they do this by lowering the activation energy.
Dang, when I see a bag of hot Cheetos, my mouth starts to water. And you want to know why? In our saliva, we have an enzyme that helps the reaction to break down starches, like these hot Cheetos, in our mouth. That's why when you see food, your mouth starts to water, to release those enzymes, to help you with digestion. Pretty neat, huh? Enzymes can be affected by temperature and by pH. Most enzymes in our body work best at our body temperature, 98.6. But they can also be affected by what pH they're in. Now, pH is measured on the pH scale. If it has a pH of lower than 7, then it's an acid, like this lemon juice. If it has a pH of over 7, then it's a base, like this milk.